Welcome my dear viewers. Today I will show you how to model, calculate load, how to analysis, design and prepare structural drawing for basement plus ground plus 2 residential building using Autodesk Robot Structural Analysis software. Modeling of this basement plus ground plus 2 residential building looks like this. There is a differential column around here, and the architectural plan contains a basement floor. So there is also a ground floor, first floor, second floor, and also the tight plans of this building looks like this, and the section is like this with a basement floor and a shear wall around this. Front elevation and other elevations of this building looks like this. To get the architectural plans of this practical project and robot structural analysis software setup, check the link in the description box and first comments of this video. Watch this video up to the end, since lastly I will tell you basic tips as a bonus. It is a time for subscribe now my channel to get daily updates, videos, and motivate me to upload more and more. Thank you. Let's dive into this practical tutorial. First, it's better to go to open a new project. So from here there are a lot of templates from robot structural analysis professional software. So from this, for reinforced concrete structure, it's better to use this template. From here, the interface of the software coming like this. So from here, you can change the interface color as you want by go to tools, then preference. From here, you can change the software color as you want. Before proceeding to modeling of your project, first you have to set all things like your building code of standard, units, and etc. So to do this, it's better to go to tools. From here, I have to go to job preference. From job preference menu, I have to go to unit and format. So from this, you can set all units like this. For example, for a structural dimension, it's better to use a metric SI unit, and for a section dimension, you can use centimeter, but in our case, it's better to use a millimeter. So for a section property also, I have to use millimeter. So here the reinforcement area, it's better to use millimeter square also. And from here for force, it's better to use kilonewton. For material, it's better to select your default codes. In our case, I have to use Eurocode. But in your case, you can use any building code of standard that you want, like Indian code of standard or other code of standard rather than Eurocode. But in our case, it's better to use Eurocode. And for concrete section, as I'm going to design concrete section, I have to use C30 grade of concrete in general, and I have to modify its letters. So for steel and the other data, timber, aluminum, you can use, or you have to set this and use it as default. And you can also change all the databases. So in our case, at the reinforcement bar, I have to use Eurocode also. So you can use any databases. From here, design code of standard. For design code of standard, that is for your section database, I have to use Eurocode standard. And for the soil database, that are databases that I want, I have to use also that of Eurocode. After this, you can set all these data as you want, then make it default parameter. After that, make it okay. After setting building code of standard and that of units, it's better to proceed to generating grid lines. So to do this, I have to click axis definition here. So from this, you have to go to check your architectural plan. It's better to use the ground floor rather than using the basement floor, since some columns are not here in basement floor but they are in the above floor. Because of this, I have to use a ground floor to generate my grid and other axis related data. So from here in x direction I have four axes, and in y direction I have 1 2 3 4 5 6 axes. I have to generate all the axes using this architectural data. So from here, the center to center spacing between A to B is S, that is 3.6, and that of between B to C is 2.6, and the last spacing, that is between C to D, is 5 meters. So from this in x direction, first I have to put position as 0 and the number of repeat, that is 0, and distance make it 0 because it's initial dimension. So the axis numbering for x direction is that. It's a lettering. So from here I have to use letters. So have to make it add. So from here I have to put the first dimension, that is making number of repeat as 1, and have to insert the distance here, that is the first spacing or distance between A to B, that is 3.6. So have to make it 3.6 meter. So make it that is the spacing between A to B. So the second spacing, that is the spacing or the distance between B to C, that is 2.6 meters. So I have to insert it here, 2.6 meter, make it that. And the last spacing, that is the spacing between C to D, that is 5 meter. And here in the architectural plan, that is 500 centimeter. So I have to insert this data also, make it 5 meter. Okay. So the total distance, that means the distance between A to D, is 11.2 meter. I will check it in the architectural plan. So okay, that is 11.2 meter. That is good. So it's better to pass to the y direction. So the y direction starts from 4 prime. It's a numeric. So starting from 4 prime, 4 double prime, 4 prime, 4, 3, 2, 1. So the spacing, the first spacing is 1.6 meter, and the second spacing is 1.4 meter. That is all the dimension here in the architectural plan is in centimeters. So I have to convert it to meter. So I have to insert the first axis, that is 4 prime. So from here I have to make it 0 to get the first axis, that is 0, 0. Axis name is 4 double prime. So click it. So the second axis, that is 4 prime, is 1.6 meter far apart from 4 double prime. So I will make it number of repeat as 1. After that, the distance is 1.6 meter. From this, I will make it add. That is, have to change this by clicking on it. So make it 4 prime. Make it okay. After that, the second grid label or axis is that axis 4, that is 1.4 meter from 4 prime. So I will change this to 1.4. So make it okay. After that, I have to click on here and change the axis name as 4. After that, the second axis is that axis 3, that is 3.8 meter or 380 centimeter far apart from axis 4. That is the distance between axis 4 and 3 is 3.8 meters. So I have to check, or I have to insert it as 3.8. Make it okay, and I have to click on here and change as 3. That is the axis name. So make it okay. After that, the second spacing, that is between 3 and 2, that is between axis 3 and 2, that is 2.7, and the last spacing is 2.3, that is between 2 and 1. So I have to insert these two spacings respectively, that is 2.7 and 2.3. So 2.7, add, have to change it as 2, and the last spacing, that is 2.30, make it okay, that is axis 1. So the spacing between the first axis, that is 4 double prime, to 1 is 11.8. I will check it from the architectural plan. So that is the last dimension, so I will check it with the architectural plan. So up to 4, that is 11.8. So 11.8, that is good. So it's better to proceed to that direction, that is that direction main. The elevations of the building, the grid assignment in X and Y direction looks like this. It's a final grid assignment, but in that direction, that is toward the elevations of the building, we are going to do this together. So from here, it's better to go to a structural story. So from the structural story, all the data are coming like this, and I have to edit using the soil data and the architectural plans of the buildings. The elevation has 3.2 meter above the ground, and 3.1 meter to the basement, that is from ground to the basement. And from the geotechnical data, the depth of foundation from the basement level is 2 meters. So using this data, we have to modify our elevation to the Z direction. So let's go to the software. So from here, building base level, that is a depth of foundation, that is 3.1 plus 2 meter, that is 5.1 meter to the negative direction from normal ground levels. So make it set. After that, you have to define all your data manually. So from here, from 5.10, our first story, that is the first story, that is from look, this is depth of the last points of depth of foundation, that is minus, yeah, minus 5.1 meter. So from here, the first story, that is the basement floor, is far apart 2 meters, since the depth of foundation is 2 meter from the basement floor. So the first story from minus 5.10, that is the depth of the base of the building, or the starting of your foundation, is 2 meters. So I will make it add. So from here, you have to get the first story level with a height of 2 meters from the basis of your building. So change it as a basement. Yes, basement. From the basement to ground level. So from the basement to ground level, we have 3.10 meter, that is 310 centimeters. So from this, have to insert 3.1. So make it okay. So I have to get ground floor here. So that is 0, top level. That is good. Make it ground floor. From a ground floor, first floor, second floor, and roof have a similar spacing, that is 3 stories. So have to insert it as or I have to repeat it as 3 times. So the spacing between it is 3.2 meters. So make it add. From here, have to change this as first floor. Yes, make it okay. And second floor, because have a similar story height. So the last story, that is roof. Roof. So starting from minus 5.10, you have to reach 9.6, that is to the roof level. But from 9.6, that is the roof level. From this, I have a water tanker above the staircase, this roof slab, that means. So it's 1.5 meter high from the roof. So I have to make it 1.5 and minimize this as 1. After that, make it add. So this is water tanker. Apply, close. So from this, you can check the 3D views of all the axes that we have going to define. Looks like this. That is good. So using these grid lines, starting from the basement floor, I will draw all the column and beam arrangements. So from the basement floor, all the column arrangement looks like this. I have 3 other columns that are start from the ground floor, but not the basement floors. So using this data, I have to draw all column and beam layouts. After this file in the description box, you can get it. So let's start draw our beam and column arrangements. Yeah. To do this, it's better to go to the robot structural analysis software. From here, it's better to go to plan view. Yes. From the basement floor. Yeah, I'm here in the basement floor. That is minus 3.1 meters from the ground level. So from here, I have to go to column. From here, I have a lot of column cross sections. Using this cross section, I have to draw columns. To define any new cross section, it's so simple. So I will show it's for column, and you can define your column and beam or wall sections in similar way. So to do this, go to section. After that, I have to change this to RC column, since we are going to design a reinforced concrete structure. And from here, go to these 3 dots. Yeah. After that, you have to select your column as RC column. Yes, after that, you have to select the material grade, that is a concrete grade, as C30, or you can select C25, but in our case, it's better to go to select C30 concrete grade. And after that, you can label, or you can name your column, yes, as column 500 by 500 by 300 as an example here. The width is 500 and the depth is 300. From the name it indicates, yeah. So using this, simply you can make it add. Sorry, it is a similar name, yes. So make it 600. So using this data, make it add simply, close. Yes. So our defined cross section coming like this. You can define it like this, but in our case, it's better to go to use 400 by 300. Yes. So click on beginning. Yeah. Click on beginning. This is from the basement floor to down, that is 2 meter, up to the depth of foundation. That means, so simply you can click here. Yes, click here, and from the architectural plan, all these 4 columns, that is in axis 3, axis 4, and 4 double prime are around in this similar manners. So axis 3, that is around this, in similar manner. So simply clicking is enough to draw your column. So all these columns are drawn like this, and the rest column have an arrangement like this. And on axis 4 to A, also arrangement like this. You can check the architectural plan here. You can get this architectural plan in the description box and the first comments of this video. So you can go back and check it. And these 3 columns have a rotated arrangement manner when we compare to this column. So have to change the section here that is 300 by 400. After that, simply click out here. Yes, it's so simple. They are drawing your column, so make it cancel. All the column is drawn like this by comparing it with the architectural plan and the defined grids from the robot structural analysis software. Let's proceed to draw our beams. To draw our beam, first it's better to go to make it 3D. Yes, make it the front here. So simply go to this, that is beam. So to save our time, it's better to use this cross section, but you can define your cross section in similar manner with that of column definition. So have to select beam 400 millimeter by 250 millimeters. So simply click on the beginning. So make it drag here. So you have to click on here, that is a horizontal beam. This is because you can uncheck this box to draw inclined beams. So to do, in our case, it's better to click on horizontal beam. So starting from here, I have to drag to the last point to draw a continuous beam. So simply click on here. Yes, right click. Yeah, click on here. Click on here. So I can draw all the continuous beams like this. Yes, and also starting from here, I have to go to here. Yes, go to here. Yeah, simply have to draw continuous beams like this. It's so simple. Yes, so you can draw like this. That is why robot structural analysis software is so simple for beginners also. So this is all about drawings of beam and column. So let's draw our slabs. This is a space for staircase. So the other spaces are part of slab, and there was also a cantilever. So to draw your slab, better to go to floor. Yes, from here I have lot of slab thickness, that is slab 160, slab 150, slab 250, 170, 180, and so on. So you can define your own thickness. So to do this, it's better to go to this three dots. Yeah. So from here you have two types of slab, that is homogeneous and orthotrophic. Yes, the orthotrophic part looks like this, and in our case it's better to use a homogeneous. Yeah. So I have to define a slab thickness, that is a slab with a thickness of 200 as an example. Yes, so I have to provide your thickness as 200, and you can change the colors of your slab. Yes, after that you have to provide you have to set your material, that is a concrete material as C25 or any way that you want. Yes, like this. After that, make it add, close. The basic point to define your slab is this, that is you have to use shell types of slabs, and you can also modify this type. You can use a stiffened diaphragm. Yes, by simply checking this box, and have to use also a one-way or two-way slab in your case. Yeah, so make it close. So have to use this slab 160. So this is the part of the stair. Yeah, so it's I will make it open, and I will show in the next tutorial part, that is how to draw our staircase and that of a shear wall. Yes, so to draw your slab, it's so simple. So you have to make it a rectangle, and you have to check the horizontal slab. This is because our slab is horizontal. You have to uncheck this box to draw inclined slabs like staircase and ramp. So to draw your slab, it's so simple. You have to click on three places. So our slab is drawn like this. Yes, it is so simple. Yeah, you can draw like this. You can draw all your slabs like this. Yes, for this panel. Yeah, and for this panel, it is so simple. by simply clicking on three places or three dots. Yes. So the modeling looks like this. It's better to go to right click here, yeah, to show all the color, make it display. Yes. From here, mark with color, so section or legend by color. So click here, make it apply. So our modeling looks like this. So after drawing all the slab, have to draw all the cantilevers. Yes, starting from axis 1, I will check the architectural plan from axis 1. The last points of the cantilever or the last edge of the cantilever is 1.4 meter. So towards the y direction, yes. So go back to the axis definitions. So starting from 0, 0, that is 11.8 plus, yes. Go back to Excel, yeah. 11.8 plus 1.4, that is 13.2, yes. This is starting from the origin, that is 4 prime. I have to add 11.8 plus this, that is 13.2. Starting from 0, 0, that is 13 point. So yes, you can draw in this way, make that. So the last point I have to get, so rename it as 1 prime, yes. And starting from y, that is starting from y, that is 11.2 plus 1 meter. You have to get this edge of your cantilever. So go back to x direction, that is from 0, 0. I have to make it 1, and from 0, 0, 11.2 plus 1, that is 12.2, yes. Make it add. So make it the small d or d prime, yes. After that, click on here, apply, close. Yes, our new grid is appeared like this. So let's draw one beam here, and you have to move it. Yes, starting from here, our cantilever is how many meter far apart from axis A? That is 2.8 meters. So after that, select this beam. Yes, from here I have to go to this edit menu. From here you can move or copy, or you can use edit. Yes, edit again, move or copy. So from this you can use this as. So I have to move it as 2.8 to x direction. So that is 1 times number of repetition. That means I have to insert this 2.8, that is from axis A. So using this, you have to make it execute. Yes, our beam is coming or moved to this direction. After that, you can draw your slab, yes, by going to floor, yeah. From this, make it apply. So you can draw by clicking 3 places, yes, yeah, 3 joints, that means. So cancel it. Yes, you can draw like this. And the second cantilever part, that is this part, you can draw it simply by go to a floor, yes, make it apply. It is so simple, clicking on 3 nodes, right click, cancel, close it. So the model looks like this, that is the 3D model looks like this, yes. The cantilever part is drawn, and in both these 2 directions. And I have to replicate this data to all the floors, and have to edit all things. So the basic point is here. This is because this is a basement floor. In the basement floor, we have not any column around here. Yes, we have not any columns around here. This 1, 2, 3 columns are not exist in the basement floor, but the basement floor has some dimension that is extend towards this, that is 95 divided by center to center, that is you have to deduct 10 centimeter to get 12.5 centimeter. That is our beam is 250 width, so I have to get this as 950 minus 12.5, that is 250 divided by 2, so 82.5. Yes, so have to draw go back to plan view. Yes, so have to draw this axis, that is the last points of the basement floor. So starting from axis 4 prime, have to measure all the dimension, that is the last points of the basement. Yes, so from here how to copy all this dimension to the basement floor. Yeah, this is so simple. So by using this center line, yes, this is so make it 12.5. Yeah, sorry, 12.5. This is the center. So starting from 4 prime, I have to know this dimension to get the last point of the basement floor. Yeah, that is 2.18 meter, starting from what? 4 double prime. Yeah, so go back to your grid. So from here it's better to go to y direction, that is starting from 4 prime. I have to put 4.18 meter, that is this dimension. That means have to get the last points of the basement line, that is this line. Yeah, so make it 1 repeats, add, yes, change the axis name, so make it apply, close. Yes, so the last territory of our basement is around here. Yes, so how to draw the beam. Yes, this is the rectangular slab also essential here. Yes, after this it's better to go to a 3D model. Yeah, I will tell you a basic point here. By simply copy all these data that I have to draw here in the basement floor to all the rest floor, and after that I have to edit all things. Yes, to do this it's better to go to basement, right click here. Yeah, please give attention here, please give attention here, it's a very important thing. Yeah, go to story, after that go to copy or contents of the story. Yes, after that make it above. This is because I have to copy this story data to the above, that is to the ground, first, second, roof, and water tanker, that is 1, 2, 3, 4, 5. So number of repetition, make it 5. After that make it okay. All things, that is all the data that may be the node, the column, the beam, and the floor is copied to the other floor. After that have to simply edit all things. Yes, this is a water tanker. From here the water tanker looks like this, but as there is no some beams, or some beams are related, I will draw some beams by you can also change the section. Yes, so you can model like this. After that there is no any beam here also. Yes, you can change, or you can draw like this, starting from here to here. Yes, starting from here to here. So the water tanker looks like this. Yes, from here it's better to go to the roof plan. So from the roof, actually the difference is that there is no the slab. This is actually a dash, so the slab is actually cancelled. Yes, it's not necessary here. And you can change also cross sections of beam. After that, we are going to assign the joint or assign the support condition. So make it in 3D, yes, and from here make it front, yes. These three columns are not part of the basement, so you can edit. You can this part, that means you can make it delete, yes, delete, and lastly I have to delete all these columns, yes. Not only these columns, but this joints also, yes. Simply select and delete. Yes, our modeling is like this. After that, it's better to go to plan view again, yes. From the plan view, go to the base. So right click on here, yes, go to joint or support, yes. From here, you have to make it fixed, apply, close. This is. So I will show it in 3D, yeah, how it looks like this. So the support looks like this. I have changed to the fixed support. For this three column, you can assign in similar way that the support condition, but in this case, the basement floor has a ground slab that is supported by the ground. So I have to delete all these slabs. It's not necessary. So I have to delete all these slabs. Yes. So it looks like this. Make it go back to plan again. So you have to go to make it delete it. Yeah, this is a node point. Yeah, so I have to select all by pressing Control key. Have to select all these three columns. So you have to make it the support condition. After that, make it 3D. Yeah. So the modeling of this building looks like. In the next tutorial parts, I will show you how to draw your staircase and how to model the shear wall on the basement floor. And lastly, we will design this building up to the end. That is, we have to download, analysis this building, and we have to design all the structural parts, and finally we have to prepare all the structural drawings using AutoCAD software. These were the most important part regarding to structural modeling using Autodesk robot structural analysis software. I hope this video is helpful for you. If you are interested, please like this video and subscribe my channel to get new updates daily. Thank you for watching.